All right, in this lesson, we're going to explore what makes triangles congruent. In a previous lesson, we learned that corresponding parts of congruent figures are congruent. We can apply that to congruent triangles and say corresponding parts of congruent triangles are congruent. So in order to prove that two triangles are congruent, I would have to prove that all of the corresponding sides are equal to each other in measure, and all of the corresponding angles are equal to each other in measure. If even one pair of corresponding sides or angles are not congruent to each other, that means the two triangles are not congruent. So let's see if we could prove that these two triangles are congruent. Let's start with the angles. So if I look here, I see angle L is a right angle, that means it measures 90 degrees, and angle H is also a right angle that measures 90 degrees, right? So we can say the measure of angle L is equal to the measure of angle H, and they both equal 90 degrees, so we know they're congruent. If I look over now at angle J is 60 degrees, and angle M is 60 degrees, so we could say the measure of angle M is equal to the measure of angle J, and they both equal 60 degrees. And now looking at the last angle here, we have angle K is 30 degrees and angle G is 30 degrees. So the measure of angle K is equal to the measure of angle G, and they equal 30 degrees. So we've shown that all corresponding angles are congruent. Now let's take a look at the sides. So if I look here at side LM, it measures 1 meter, and here side HJ also measures 1 meter. So I could say here LM is equal to HJ, and they both measure 1 meter. So let's take a look at this side here. So here we have LK is 1.7 meters and HG is also 1.7 meters. So LK is equal to HG, and they both equal 1.7 meters. And finally, we have here MK, or KM, however you want to say it, is 2 meters, and GL is 2 meters. So we can say KM is equal to GL, and they both equal 2 meters. So we have shown that all corresponding sides of these two triangles are congruent to each other, and all corresponding angles of these two triangles are congruent to each other. So now we know that these two triangles are congruent. So we can state that triangle GHJ is congruent to triangle KLM. So then now, are these two triangles congruent? So let's see. Well, we can see that AB is equal to ED because they're both 12.1 centimeters. And AC is equal to DF because they both measure 7.9 centimeters. But now look at BC and EF. BC measures 8.5 centimeters and EF measures 8.4 centimeters. So BC is not equal to EF. Therefore, these two triangles are not congruent. Let's take a look at this example here on the coordinate plane and try to determine if these two triangles are congruent. So let's start with the angles, the easy ones here. I know that angle B is a right angle because of the coordinate plane, and in the same way, I know that angle E on this triangle is a right angle. Now, angle F on this triangle is 26.6 degrees, and angle A on the other triangle is 63.4 degrees. So what we have here is we have two missing angles. So we need to go ahead and figure this out. Remember that the sum of all three angles in any triangle is 180 degrees. So if I add angle E and angle F together, 90 plus 26.6, I get 116.6. And if I subtract that from 180, I get 63.4. So now I know the measure of this angle here, angle D, is 63.4 degrees. And if I follow the same process on this triangle, I will see that this angle here measures 26.6 degrees. So I can see that corresponding angles are all congruent. Angle C and angle F both measure 26.6 degrees. Angle B and angle E both measure 90 degrees. And angle A and angle D both measure 63.4 degrees. Now let's take a look at the sides. I can see here on the coordinate plane that side AB is 3 units long. And the same goes for side ED. They are 3 units long. I can also very easily take a look at side BC is 1, 2, 3, 4, 5, 6 units long. And side EF is also 6 units long. Now, as far as side AC and side DF are concerned, I could use the distance formula to find the length of each side, or I could just use some common sense. I see that side AC is the hypotenuse of this right triangle, and side DF is the hypotenuse of this right triangle. And each right triangle has a leg that measures 3 units and a leg that measures 6 units. Therefore, each right triangle's hypotenuse is going to be the same length. So I know that side AC is congruent to side DF. So we've proven that all corresponding angles are congruent and all corresponding sides are congruent. Therefore, we can state that triangle ABC is congruent to triangle DEF. All right, so in this example here, we need to find the value of the variable x that will make both of these triangles congruent. So we need to make sure that all other corresponding parts are congruent. So we can see here that JL and MP are both marked with 1 bar. They are corresponding and congruent. JK and MN are both marked with 2 bars. They are corresponding and congruent. KL and NP are both marked with 3 bars. They are corresponding and congruent. If we look at angles J and M, they both measure 55 degrees, and they are both in between the same 2 pairs of corresponding and congruent sides. JL and MP, and then JK and MN. And in the same way, K and N are also corresponding and congruent. So that tells us that P and L are also corresponding angles. So we need to set them equal to each other in order to make these two triangles congruent. First, we need to find the measure of angle L using the triangle sum theorem, which tells us that the sum of all 3 angles in any triangle is always 180 degrees. So we can write the equation, the measure of angle J, 55 degrees, plus the measure of angle K, 45 degrees, plus the measure of angle L has to equal 180 degrees. 55 degrees plus 45 degrees, that's 100 degrees. plus the measure of angle L, that equals 180 degrees. We subtract 100 degrees from both sides. And we see that the measure of angle L is 80 degrees. Now we can set our equation and solve for x. So if angle P is supposed to be congruent to angle L, so we can write 5x plus 30 equals 80. So we're going to subtract 30 from both sides. And we get 5x equals 50. And then we divide by 5. And we get x equals 10. So the value of the variable x that would make both of these triangles congruent is 10. All right, in this last example here, we see that angle A on this triangle corresponds to angle D, and they're congruent. Angle C corresponds to angle F, and they're congruent. And angle B corresponds to angle E, and they're congruent. And then so we can look for some corresponding sides. AC corresponds to DF, and they both measure 50. BC corresponds to FE, and they both measure 30. And so that leaves DE and AB. And so we can see that AB measures 36 millimeters, and DE, we need to figure out what the value of Y is to make these two triangles congruent. In order for these two triangles to be congruent, side DE must equal side AB. So we can write the equation. 2y plus 20 equals 36. And we solve. So we're going to subtract 20 from both sides. We get 2y equals 16. And then we divide both sides by 2. And we get y equals 8. So the value y needs to have in order to make both of these triangles congruent is y must equal 8.